Craig Cadieux, who's a local guy up in the Bridgewater area, recently from the nonprofit sector of Hooray, which is a local renewable energy association based up in Plymouth that's done a lot of good work over the year. And he has recently joined up with Revision Energy as of about a month ago. And so now he's got his private sector hat on, but he's got deep experience in facilities management and working with commercial buildings all over the region, all over the country, and obviously looking at energy savings and how to more efficiently operate a building and manufacture things like that. So he brings a ton of practical experience and knowledge about the broader field of energy, and even more specifically some projects in this area that he's going to be able to talk about. Craig lives in the Newfound watershed with his wife Heather, and they've been up here 15 or 20 years, so quite a long time. Another one of those hidden gems that we find as we get to meet people around the area. They heat their entire house with a wood pellet boiler and have solar thermal and solar electric systems. And as he says, increasing the energy efficiency of their 1970-era home continues to be the focus of most home improvement projects, which makes a lot of sense. So Craig's got the floor. We've got him here for about an hour. I probably won't talk that whole time, but we'll have time for questions and answers and discussion. Let's take advantage of this opportunity to learn how we can apply solar energy into our lives. So Craig, the floor is yours. Thank you very much.
Thank you, boy. Good evening, everyone. Again, I just want to thank you for taking this rainy, cold night and coming out. I know we as New Englanders are always anticipating this, but it's always hard to leave our homes in the evening when we've got nights like tonight. We got two organizations here, Newfound Lakes Region Association and Revision Energy. I've sort of restated Newfound Lakes Region Association's mission statement, promoting conservation and preservation of Newfound Lakes region's natural, social, and economic resources. And one of the key missions that Revision Energy has is we're a mechanical contracting company, and with our primary mission is to reduce CO2 emissions in northern New England. So we're a good dovetail. We have Revision Energy has got 3 offices. We originally started in Portland, Maine. We branched out to Liberty, Maine, and we opened an office about 3 years ago down in Exeter. And our primary focus is northern New England, Maine, New Hampshire, and we're trying to move a little bit more over into Vermont. One of the key things, I just want to do a little bit of a plug for Revision Energy. Here again, our primary mission is reducing fossil fuels in the Northeast. We've been in business since 2003. We've installed more than 3,500 systems over that entire region. All the company partners are engineered, so most of the systems that we have been thoroughly vetted and engineered out. All our company employees have ownership equity in the company. So when our installers come out, they've got a real incentive to do what is right for you. We have master trade licenses, electricians and plumbers, and most of them have independent certifications. We offer 5-year warranties on our systems. Most of our products are resourced right from the manufacturers as opposed to involving middlemen, so we can keep our prices as reasonable as possible. We do both residential, commercial, municipalities, and nonprofits, and we offer a variety of financing options. So why is New Hampshire going solar? We are one of the most oil-dependent states in the country. 58% of our homes are heated by oil. Our electricity costs are 30% higher than just about any place else in the country as well. We import 1.6 million gallons of liquid fossil fuels into the state every year. And the key takeaway from tonight is $2.35 billion, which originally comes into our pockets, is leaving the state. And the whole idea with trying to reduce our energy use, produce our own, is to keep more of those dollars in our own economy. Good news. New Hampshire has abundant resources in par with the French Riviera. We're actually, Germany has the largest per capita solar installations than any place else in the world. And they are actually higher than we are. They get less sunlight. So it's working in Germany, it's definitely workable here. It's sun. infinite fuel supply of energy. If anybody knows when the sun's going to go out, please let me know. I'd like a little bit of warning. This is a great graph. It's been floating around the industry for a while, but it sort of gives you a relationship to our available energy resources. Clearly the sun is very dominant, but you can see the other variety of fuels, primarily limited fossil fuels, that we believe are in reserves. You can see that we have lots of sun and there's no diminishing of that particular resource, where these others are all limited resources and eventually we will run out. So how can we use the sun to either reduce or eliminate our fossil fuel use? And there's three primary ways. We can make electricity from it, we can make hot water, and with that we can also heat and air condition our homes. There's not too many other places in our homes where we use energy except for any of those three. So we're going to start off with solar electricity. When we generate solar electricity, we call it photovoltaic. I may jump into that phrase calling it PV every once in a while. But it starts off with a solar panel. I've got examples of smaller ones. Full-size ones for homes are around this large, or about 3.5 feet by 5.5 feet. But this is an example of a smaller one that it's easier to cart around. So when you have a solar panel, sometimes referred to as solar modules, when you take a number of those and you group them together, we refer to those as solar arrays. So this is where you start off with a solar array. From there, the solar panels and the solar array will generate DC, direct current power, similar to what's in your car battery. From there, we need to convert it to AC power, alternating current that can be used in your home. And we do that with the use of an inverter. So this is a box that's tied in right after the solar panels, and it does the conversion of the DC to AC power. From there, we actually tie it right into the electric panel. Everybody should have something that looks similar to this in their homes. And after we've converted the power, we tie it right into the electric panel. And then from there, whatever you don't use, the power will go through and you use it in your house. That's great. That's the whole intent of having solar electric. And if you happen to be using or making more than you're using, that excess goes back through your meter, spins your meter backwards, goes back into the grid, and provides you with a credit on your electric meter. And then those times, like the evening or this time of the year, when you're using more than you're making, you get those credits back. It's a 1-for-1 ratio. You pay retail and you get a retail price back. So this is another diagram very similar to what I mentioned before. DC power at the panels through the inverter. Main panel, use what you're making, excess goes through your utility meter and back into the utility grid. A couple things about the current places where we get power. The average fossil fuel plant converts only about 40% of its potential energy into electric power. Now when we talk about energy efficiency of conversion, we're going to take some type of raw fuel, oil, coal, natural gas, and there's a process of usually burning it, and then you need to convert it into what you want, in this case electricity. And when we talk about increasing the energy efficiency of something, we're talking about how good a conversion can we do? How well can we convert that energy that is in that raw material to energy that we can use? And with electric power plants, this is primarily coal, natural gas is getting a little bit better. We're only talking about a 40% conversion rate. Then from the main central power plant, it goes to power lines, and we lose an additional 6% just in the transportation of the power. Energy generated at your site stays at your home. There's very little loss between your solar panels and your panel. So it's a very efficient way to make electricity for your home. So what I just described is more commonly referred to as a grid-tied net metered system. And generally what that means is grid-tied is tied right into you through your electric panel into the electric grid. And net meter means you get the power 1-for-1 which you produce, you also get it back. So it's not like you're selling wholesale and only getting a portion of that revenue back. You're getting it wholesale back. This is a law in New Hampshire. It says if you generate energy on your site, the utilities have to pay for it. They give it to you, they give you those credits. Couple limits on this though. If you produce more than you use in your house, you don't get that retail price. You can either roll it over to the next year, or you can actually get reimbursed for it at a closer to wholesale rate, about a third of your retail rate. One of the other downsides to a grid-tied net meter system is if there's no power on the grid, your solar system goes down as well. And the primary reason for that is if the grid is down for some reason, more than likely there's a problem, and we have linemen trying to correct the problem. And they don't want to have a solar system that's feeding into the grid, potentially going back into those lines and electrocuting someone. So one of the key functions of that inverter that I mentioned was it is constantly sensing the electric power on the grid. And if it senses that it goes down, it shuts it off entirely. You can have what we refer to as a hybrid system. So this is a grid-tied and net-metered system that also has a battery bank to it. So if the power does go down, you have a set of batteries that go to it. This adds significantly to the cost of the system. For most people, what I talk to them about is, give consideration if the power doesn't go down a lot, and this just happens occasionally, you're almost better off than just buying a generator and just use it on those few occasions. Because there's a lot of things that go into batteries. What do you want to run during a power outage? Is it just a matter of keeping your furnace or refrigerators running, or you want a lot of other things in your house? Then you need to ask yourself is, how many days do I want to be autonomous? Do I want this thing to run for 3, 4, 5 days a week? All that sort of influences how large a battery system you would need. During what time of the year do you expect to have a power outage? Here again, you'd expect your solar panels when the sun is out to be able to recharge your batteries. But there is very little solar energy in December. And in my experience, I see most of the time it's the December time frame, maybe January, when we lose power for one reason or the other. And it's the time that you have the least amount of solar energy. And the other key thing with batteries is how much do you want to be involved in maintaining your batteries? You can pay a lot more money and have more maintenance-free batteries, or spend a little bit less money and you're going to be involved with your batteries, constantly checking to make sure that they're functioning properly. So as I said, it's a possibility, but I have a tendency to steer people away from it. Then the third one is a completely off-the-grid system. This basically means you're cutting the ties to the utility grid. It's a great way to live. I've often thought about it, but there's some real serious lifestyle changes. I sort of related to, you're getting sent off into the desert for 3 days, you're going to be there, and you got 5 gallons of water. And you're sort of saying, how am I going to use that 5 gallons of water? Right off the bat, someone says, well, I'm not going to be washing my hands with it, and I'm not going to be soaking myself with it, I'm going to be using it strictly for drinking. And the question is, where does your priority go if all of a sudden that bucket of water gets a leak in it? If you're in the middle of the desert, all things stop and you find out where that water is going because it's a limited resource. Here again, you're not tied to the grid. You'll probably never know if there's a power outage, but you need to be very conscious about what your energy usage is. Solar hot water. We talked about solar electricity and solar hot water. 2 types of collectors for collecting the sun's energy. For solar hot water, evacuated tubes and flat plate panels. Both of these are available. Both have pros and cons. Evacuated tubes have been around 20, 30 years. Work really well in New England. The problem with these is they have a tendency to collect snow. They don't necessarily shed off as well in the wintertime. Flatbed collectors have been around for more than 400 years. Yes, they were actually installing these in the late 1800s before everybody realized that oil and coal was much easier to deal with than solar. These work very well. They work equally as well in the summertime, a little less efficient in the winter, but the key thing with these is they'll shed the snow. So, where this one will have a tendency to collect snow, this will shed snow and you'll continue to make hot water. So from there, we need to put it into a tank. Usually it's a set of pipes, 2 pipes of supply and return. This connects the panels to a tank. We usually have a solar storage tank, which is a regular hot water tank, and there's a set of coils that are usually immersed in the bottom of the tank. I'm surprised I'm not coughing more than I am already. I'm getting over a little bit of a cold. So we connect these two with a set of pipes. We run it's usually glycol, antifreeze that we run through it so it doesn't freeze in the wintertime. It runs through the bottom of the tank, heats the water, and as the water warms up, it actually rises to the top of the tank. So the next picture I've got, I should tie these together. So you got the collector of the tank, and here's the diagram of the solar supply going out to the panels. Actually, it's actually backwards. So the solar supply is actually feeding the top of your solar tank, and then it's returning up to the bottom of the collector. And in between, what we actually got is a controller, and what the controller has is thermal sensors. One that is located up in the panel, and the other one is located in the tank. And this actually controls the operation of a pump. So it constantly looks at those 2 temperatures. And the pump only turns on when the panel temperature is higher than your tank temperature. And when those temperatures drop again, it actually shuts the pump off so that you don't end up cooling down your tank. From there, it's hot water out. And usually you need to consider these as a preheater for your primary hot water. So the question is, what do you do with the next one? You still need your existing electric system or some other type of system. The most common way to address this is actually, they have tanks where they actually put an electric element halfway in the middle of the tank. And what this does is it allows you to gain as much as you can from the solar at the bottom of the tank, and then it always makes sure that there's a certain amount of hot water to take care of your needs at the top of the tank. So it's one tank system. You make sure you've got the electric element to give you the hot water you need, and you take advantage of solar as much as you can. So moving a little bit into evaluating potential solar sites, and this is what my primary responsibility is as a solar designer. My primary objective is, where can I place panels or collectors on a person's property? This can be on the ground, on the roof, or wherever they happen to go, so we can harvest the most energy from the sun. And this is the criteria I look for. I'm looking for a site that faces south, plus or minus 25 degrees. Shading, the site is not shaded any more than 20% of the time. Regardless, if you put that panel there, you're going to be producing power. But ideally, at the end of the day, if you're looking at the cost benefit of installing solar, you really want to limit the shading. So I'm looking for a site that only has shading on it maybe 20% of the time. And the key hours are between 9 and 3. That time between 9 and 3 is called the solar window. And that is when you're going to get 80% of your power is during those hours. So if you've got a tree or something else blocking during that time frame, that's going to have a greater impact on your site than something that's more to the west or more to the east. One of the things I do when I go out to a site, and that you would get from working with someone who does the work I do, is what we call a shading analysis or a solar access analysis. It's this device. It's about $2 grand, but what it's got is a little fisheye on the top, and what you're seeing here is sort of the southern end of that fisheye, and the yellow area is every place the sun would show throughout the entire year on the particular site that I'm standing on. So the lines that you see that run from the left to the right, from bottom to the top, represent the months of the year. And we've got at the very bottom June, which has the days which are the longest in the year, and the longest line on the bottom. Then we alternate alternating months until we get up to December, which has got the shortest day of the year. And we've got the hours of the day. So you see noontime here, and we go morning hours to afternoon hours. What I'm looking at are all the things that may be shading this particular site. So I can tell, if I look at the summertime, right down here, I've got a tree here. It's already, this system's already identified that there's going to be leaves on this tree. It says in June, I'm not going to have sun on the site till a little after 9 o'clock in the morning. You can see in December that I'm not going to have sun on this site until just before noon. And then I have some diffused light a little bit before noon, and I'm only getting about 3 hours worth of sun in the midwinter time. All in all, this takes a large database that's packed into this thing. There's been an organization called the National Renewable Energies Laboratory. It's been collecting solar energy data for more than 50 years down in Concord. There's a number of other sites around the state that also have collected this data. But all packed into this thing is the hour-by-hour data for how much energy we're receiving. So it factors in where all this shading is, factors in at what time during the year, and it comes up what we call a solar access number. And this is saying 80%. If this was facing due south, and I was at an angle about 40 degrees, and I had no shading at all, we would call that a 100% site. And from there, I can actually do some calculations on how much energy you can expect to produce for your particular system. And what this is telling me is I'm getting 80% of the optimal, which is still what we consider pretty good. Well, actually, more than pretty good. This is a good solar site. So this is one of the key things that we look at when I come out and do a site evaluation. This is another way we take a look at sites. Usually a lot of our customers who call in, first thing we do is we call up a satellite picture and we look at the particular house. So if I look at this neighborhood here, I can look at the various roof surfaces and the properties that are here, and I can pretty quickly identify what roof surfaces may be strong potentials for solar, as well as what properties may have potentials for ground mounts. So if I look at this house up here, this is south at the bottom, it's just generally oriented south-north at the top. There's one large roof surface here that's facing due south, which is a good location for solar. One little clue I got to look at, though, is there's some trees that are shading here. So this may be a good site, and the conversation I may have with the customer is, were you thinking about taking down some of these trees here to improve your site? This site over here is not facing due south, but I think it's within that 25-degree range either way. I would call this a pretty good site. And I look around over here, and the trees are as far away. There's a little bit over here on the west side, but there's a good chance that I go out with my shading analysis tool, I'll get up in that 80% range. This house right here, not so much because of the direction it faces. This house here is a little bit of a challenge, but I also see there's a potential in this area for possibly putting a ground mount. The nice thing with a ground mount is you can face it due south. You can get that perfect angle. What I'm looking at here is the trees are far enough away where it may not be impacting it. Shading may not be impacting the solar collector. And again, everybody's Google Maps. Take a look at your house. You can do a lot of the analysis yourself just by looking at the picture of your home. Secondary objectives. Usually we design for one of three things when we go out. We either design to meet the current or future needs of the home. So as I mentioned before, the ideal system is something that takes care of all of your energy needs. So when you look at an electric bill for your home, we calculate how many kilowatt hours you use in a year, and we can make and then we also ask the customer, do you have a future, do you have a growing family? Do you plan to start heating your house with electricity where you may want to use more electricity to heat your home? What are those changes? We design the system to its current or future use. The second criteria we use is the maximum available space. Not everybody has all the space they need on the roof to meet all their needs. So very often the limiting factor is just how much space you have to put these solar collectors. And then the third one comes down to is the design to budget. You only have so much money. There's nothing wrong with doing a system that only does half your power. Half your power comes from a renewable energy source. The other half comes from the grid. and very often we have to adjust to a budget. Nothing wrong with that as well. So here's a picture here of, I think there's 20 panels here, which is usually which take care of about the average size home. I shouldn't say the average size. The average user, or the average consumption of homes in New Hampshire is crazy. And then right over here is our 2 flat plate collectors that also do the hot water for the house. They take care of the hot water needs. A couple financial considerations when we're looking at solar. The nice thing with solar is you're primarily buying, you're setting your rate for electricity. Regardless of what the rates do on electricity, yours is going to stay the same. You made your upfront investment to install solar, and that's the only thing you're going to have to pay from this point forward. The utility will charge you a meter charge to have that meter on there, but if the electric rates go up to $1 a kilowatt hour, it's not going to matter to you because you're making your own. So you're basically fixing the rate for the life of the system. And we're talking probably in the 35-year range. It's not uncommon to see these systems last. Right now, there is a 30% federal tax credit through 2016. That's only 2 years from now. And what this is, if you have the tax liability, this is basically you getting taxes back for 1/3 the cost of the system. Don't forget, 2016. Don't forget, we also have another big event that's going to happen in 2016, which is another big election that we just went through. So my gut feeling is people aren't going to be focusing on renewing this credit at that point in time. So there is a limit on this. Currently, there are state incentives. They're up to $3,750. There's the fine print there. It's 75 cents a watt. One of the key things to remember is the state is looking for solar sites that have got at least 80%. So remember back when I was doing my site analysis, these installers will fill out all the applications and get these rebates for you, but we need to demonstrate to the state that you've got a site that's receiving at least 80% of the available sunlight on your spot. Anybody live in the New Hampshire Electric Co-op region? Co-op? Co-op has been a very good partner. It's a member-owned utility as opposed to PSNH or the other utilities in the state. They actually offer incentives up to $2,750. So if you live in the co-op territory, you have access to a 30% federal tax credit, the state incentive, and there's an incentive for the co-op. These are limited pools of money. Generally, they've been pretty good about keeping them full. They have come down a little bit because the whole idea is to spur on this market. But these renew on an annual basis. These renew around July 1st. Is that the right time?
Pretty darn close.
Yeah, all right. The other thing, financial consideration of, what's the price of electricity going to do over the next 5, 10, 15 years? I don't think any of us know unless anybody's got a crystal ball, but I don't think it's going to go down, and it doesn't look like it's going to stay still. So we're constantly dealing with increasing costs of electricity.
Did it just go up 45% or something like that?
One of the utilities, I think they just went up that way, in that realm. I've been, part of my analysis is I look at your electric bill and I try to figure out what your rate is so I can do the financial calculations. And I've been seeing anywhere between 60 and 20 cents a kilowatt hour. And that was down, very often I was seeing 12 and 13 cents like a couple of years ago. And then the last one, as I mentioned, $2.25 billion is leaving New Hampshire. By having your own solar system, that's money that's staying in the state. So it's a matter of how much money do we want to either keep in the state and have leave the state. Environmental and social considerations. We've reduced our carbon dioxide potential, regardless if you believe in global warming or not. There's excess carbon, CO2 that we're pumping into the atmosphere, and this is one way to take a chunk out of how much we're putting in the atmosphere. There's no need for large transmission lines. Everybody knows what happened in Plymouth when the windmills went over there, what those transmission looks like. We reduce the chances that we need the power coming down from Northern Pass. The more people that do this, the less our needs are, the less we have to increase those power transmission lines. Less need for centralized power. We make better use of the fossil fuels we have. We're not dealing with that conversion rate of close to 40%. We have less need to build more centralized plants. Increasing the efficiency of how we use. The energy you make on your site stays in your site. It's a 1-for-1 ratio. It's a great way to use energy. Reducing the needs to scar our landscape. Everybody knows what I'm talking about here, being part of this community. The money that comes into our community stays in our community and enhances everyone's quality of life. So, cost. This is an example of a 5 kilowatt system. This is how we measure solar in kilowatts. Each kilowatt produces so many kilowatt hours is what we pay for. This system produces about 6,000 kilowatt hours per year. This is about the state average on how much people use. A good homework lesson for everybody to do is go back and take a look at their bill and see how you sort of, measure up with what the average is. So this is kind of where we find the average size system. So the estimated cost of this, there's a number of things that factor into it. Obviously, people with higher roofs end up being a little bit more expensive because there's more labor involved. If you've got an older electric system, sometimes upgrades need to get done. So this kind of factors in sort of a ballpark figure. So the initial cost will be about $18,250. And in this case, we're not in the co-op territory, say it's a PSNH. There's your federal tax credit, $5,475. State incentive, this would qualify for the max state incentive, $3,750. So your final cost would be somewhere close to $9,000. At 16 cents a kilowatt hour, which I just indicated is a little bit on the low side, this means that you're saving about $960 per year. One of the other things that Revision Energy has got is called Own Your Own Solar Loans. It's a financing program that we've got that allows you to get into solar or have solar installed on your site. 0%, zero down payment. It provides a year's worth of interest-free loan, and then it converts into this is 12 months, it should be 12 years. 0% financing for 12 years. Interest rate 2.99. And it's up to $50,000, which you saw with another scenario, is quite broad and allows you to do a lot of other things. A couple things to keep an eye on as we move forward. New Hampshire has a law in its book. It's called Group Net Metering. This just became a law back July of last year. And what Group Net Metering does is it allows a large solar system to be placed in one location with one meter, and multiple people who have electric meters can benefit from it. It was originally designed for municipalities and businesses with a thought that you have one good solar site, other sites within your community, or if you had a business, one business may have a good solar site, others may not, and that allows those other meters to benefit from it. So one site and one meter provides solar energy for multiple meters. The place to stay tuned is, and what we're all looking forward to, is not everybody's got a good solar site. And when it's starting to take hold, it's not quite there for New Hampshire, but it's coming. It's called community solar. And this provides an opportunity for a group of people to get together. They may not have a good site. Find a good site. Everybody invests in that one solar system, and everybody gets to benefit from it. So they're scratching through some little hiccups in the law right now that make this a little bit difficult, but this is coming. Solar for businesses. This is an example of a flat roof. There's a lot of these throughout the country and throughout New England. Put panels up on a big flat roof, nobody sees them, it's big empty space. Might as well put panels up there. These businesses are eligible for the 30% federal tax credit. There are incentives in the state up to $50,000 for businesses. They also have the opportunity to reap the tax savings because they can accelerate the depreciation on these systems for up to 5 years. And very often you can find financing ways. So it's a cash positive where you're actually making more money and you're saving more money to cover the financing. Great opportunity for businesses. throughout the nation. Options for schools, towns, and nonprofits. The reason I got these folks as a different categories because they really can't take advantage of the 30% federal tax credit. But the Public Utilities Commission does have grants that are available that these various organizations can apply for that sort of bring that cost down. And there's also what we refer to as power purchase agreements, which are basically you lease your roof or you lease your space to a company that does have the tax appetite and can take advantage of that tax benefit. What they do is they give you a set rate of electricity for like 6 years or 10 years, and then after that period of time, you own the system. Primarily, they want to come in and get out, and they want to take advantage of the tax benefit. Great opportunity for these folks that don't have the tax appetite. Just to point out right now, the town of Bristol, the Energy Committee, has made a proposal to the Select Board to install a large system down by the wastewater treatment facility. And the Energy Commission has actually applied for one of these grants. The objective, as far as I know, is they want to have a system large enough so they can use group net metering, offset the electricity from all the other meters in the town of Bristol. And the objective is, at the end of the day, is to reduce the operating costs, which hopefully will reduce taxes, on all the electric usage in the town. The town of Hebron, I think, is looking into this right now, and it's becoming a conversation in a lot of energy committees and other communities. So to get started, determine if you have a reasonably good solar site. I gave you most of that information now. Facing south, minimal shading. Get a copy of your recent electric bill. Educate yourself. Try to figure out how many kilowatt hours a year you're using. Start moving away from how much is this costing me and look more at how much am I using, what's affecting my usage. Get more up to speed on that. And the next is requesting a solar site visit. If you think you've got a good site, with Revision Energy, you can go to our website and we've got this simple form. Fill this out. Someone will call you. They'll review your electric bill with you, take a look at your site on a satellite photograph, and then we can arrange to put together a proposal for you. And the other key thing, as I mentioned a little bit earlier, is supporting and encouraging your town energy committees and leaders to reduce their energy use. That's the biggest bang for the buck, reducing your energy use, and then finding ways to make it their own. That's it that I've got. I'll be happy to take any questions.
Thank you, Craig. That's first of all.
The 40% number you use for a standard conventional power plant, that somehow is lower than I guess I've always.
Things have been improving. Natural gas plants are starting to get more energy efficient. This is probably that 40% I probably got from a standard coal plant.
But the math for calculating that, you take an assumed capacity number and hang that up there and then determine how much power it's actually producing,
Right.
and that's the 40%?
Right. Potential energy in the fuel versus the energy that's coming out.
Potential energy in fuel.
Right. Versus the energy that's actually coming out. Here again, you look at the other power sources. Hydro is actually pretty energy efficient. Like I said, the natural gas plants that are starting to get built now are more energy efficient. But a lot of our plants, especially the older ones, were built in a day when we had cheap energy. And the energy efficiency aspect of it was never really consideration. Fuel's cheap, we can pump it out, people will pay for it.
So the wind number is 30%, right?
I'm not exactly sure. Yeah.
Potential output versus what they actually get. Because wind doesn't blow all the time.
Right. But the thing with both wind and solar is you're not really paying for that initial fuel. There's clearly an upfront cost, but the fuel that you use to generate the energy, there's no cost to it.
On an $18,000 system with zero down financing, Are you financing 18 or 9? Who's getting the tax credits?
You would get the tax credits. And what happens is the way the loan is set up, you actually get 0% financing for the first year. And the intent of that is to give you the time to get the state rebates as well as the federal tax credit. And then whatever net after that gets financed. That's right.
When the solar panels are in operation and you are using the electricity in your house, now through that inverter, as the day gets cloudy, clears back up, the inverter takes over, making sure that you have steady power through the house? Like, so that you're not getting like brownouts during the day and, where the energy tends to dip and so as you're drawing off of the grid, but then now you're producing electricity from your panels.
Yeah.
You're producing more than the grid is providing to you at the time. But then it gets cloudy. The inverter then reduces the power. So when it gets cloudy, then the inverter. So I'm just trying to understand, how much control does that inverter have over the actual level of power that you're receiving as far as?
Very little. You won't see brownouts, you won't see blackouts. If it gets cloudy, we have days like today, you just have less.
The lights don't dim in the house.
Lights won't dim, you'll never know. It just, the only thing that's going to happen is your meter's going to go one way or the other. And in a cloudy day like today, I've got a system on my house that's making about 500 watts, and I was using more than that, and my meter was, was offsetting a little bit, but not a lot. In the summertime, it's constantly spinning backwards.
The other question I have is people with shingled roofs. When you're installing a unit on top of a shingle roof, and your roof gets to the point where it needs to be re-shingled, that all has to be removed and then reinstalled to get a particular roof, which increases the costs.
Yes.
In that.
Right. There's one of the conversations I have with people, and usually the life of the system is somewhat dictated by your roof. If someone's got a roof that's more than 10 years old, you need to think about replacing it with solar on it, because you got a system that's going to last 25 to 35 years.
Yeah.
One of the advantages to solar is that the biggest thing that degrades the life of your shingles is the sun. So if you got panels over it, you should be increasing the life of your panels. I mean, electricity life of your shingles. With that said, though, there's usually a border around the panels, so those will still be exposed. So, when the time comes. I think what's going to happen in that market is, you want 25 years out of your roof and look for 25 years out of the solar panels. And I think what's going to really happen is there's going to be companies out there that will come, take your panels off, give you some money for those. You're going to re-roof, and then you'll probably put new panels on to go another 25 years. So I think that's going to go.
Cost-wise, having a rate bill.
Put a metal roof on. Or go with a ground mount. You got a steel structure that's going to last, longer than the panels.
In a ground mount, you could have an adjustable array, adjust to the angle. And so what's the percentage of difference in not adjusting? Say just having a panel that I think you said for 40 degrees.
40 degrees. Most of the systems we've been talking about are what we refer to as fixed panels. They're in one location. For panels to reach their optimum output, you generally want them facing 90 degrees to the sun. They will still produce if they're not facing 90 degrees, but when it's a bell curve. If you watch the power output, from morning it'll be low, and then when you get to noontime is when your highest output is, and that's because you're more 90 degrees to the panel. And then it starts to drop off as you get that angle away. What the gentleman is referring to is there's two types of systems that will actually track the sun. So you can have a single axis tracker, which usually says, bear in mind in the summertime the sun is high in the sky, so we'll actually make the panels a little bit flatter to get more 90 degrees to the sun. and then you can actually tip them up so they're a little bit more horizontal in the winter because the sun is lower on the horizon. So that's a single axis tracker. They also have double axis trackers or dual axis that follow the sun from morning all the way through till the afternoon, and their objective is to stay as close to 90 degrees to the sun as possible. On a good site, and I talked about you're getting the sun in the morning from the second it comes up, and when the charts say at sunrise till the afternoon, you can actually increase the production by about 40%. Generally what I see when I do my analysis, and I factor in the efficiency with trackers, you can generally see 20 or 30% increase in production. So the question comes down to, it's more money for a tracking system. The question comes down to, do you have more room to put more panels on, or does it make sense to buy something that's mechanical for a ground mount and try to get that extra production? Is that, it's a long-winded answer.
Yeah, it does. It's about, so the single axis would be perhaps 20% gain if you...
You're moving it by hand, so assuming you move it 4 times a year. Here again, I can do the calculations. This thing allows me to do the calculations, but I would assume maybe a 20% increase if you were diligent about moving it. Yes.
Can you talk a little bit about how it actually works? Is it the heat of the sun? Is it rays? Is it ultraviolet? Is it what works? And compare that to summer and winter.
Yeah.
And then also, if you get a 3-foot snowstorm, what happens?
Yep. It's actually ultraviolet light. It's a reaction between 2 plates of silica. And when the ultraviolet light hits it, it excites the electrons and they transfer from one plate to the other. And that transfers into electricity that's transmitted to the system. Again, the more 90 degrees of the panel and the more energy that it's getting, the more those electrons are excited and the more power you can produce. So winter versus summer, I think we all know there's, the sun is lower in the sky, we have less sun, and it's also less warm in the wintertime, and that's all related to the ultraviolet light that's coming through the atmosphere. The sun is actually further away from us in the wintertime than in the summertime as well. So there's less production in the wintertime. The key thing with grid-tied, net-metered solar is don't get hung up on how much energy am I producing in the summer and the winter. We're looking for the average over the entire year. What will end up happening is you'll be making all kinds of energy in the summer and you'll be banking it through net metering. And then in the wintertime, when we start getting into this time frame, you're actually buying those credits, getting those credits back. So that's why I mentioned before, we look at systems, how much energy do you use in a year and should we design for that system? Now, as far as snow, the systems, if they're mounted on your roof, one of the things we do is an evaluation of your roof to make sure that it can take the snow. The actual weight of the panels themselves is very little. And the roof, if it's taken snow loads before, should be able to take snow loads in the future, even with the additional panels that are on them. And they're very sturdy. They'll take whatever snow load ends up being on them. The snow will slide off the panels, just like a metal roof. If it's sliding off a metal roof, they'll slide off the panels. So there's another consideration. You got an asphalt roof now, and the snow melts gradually off your roof. You're now adding a slippery surface. You need to ask yourself, is it okay on my property for the snow to come off in a large chunk and land where it is? So last winter was kind of weird. We got a lot of calls from people. We had one weird storm where it was a slushy snow, it rained, and then it froze. And it was just this solid block of ice underneath these. And looking around, it was the same way with people with metal roofs. The snow was just sticking to it. And it just required one sunny day or a couple sunny days for the snow to finally slide off. Anything else?
I've heard that from a legislative standpoint, we're reaching the end of what was agreed on, 50 megawatt max for all comers.
Yes.
And is it likely that credit will go away once that maximum is reached? Or will it be re-upped again?
Let me just provide a little bit of a background so we get everybody on the same page. There is a standard in New Hampshire called the Renewable Energy Standard, and it requires the utilities to purchase so much of their power from renewable energy sources. It's at 25% by 2025, and it's actually a scaled process. And what's happening is with a lot more people getting into solar, these utilities are getting the credit for that renewable energy credit, and we're starting to bump up against what those maximums are. So there may be a point in time where the utilities have said, hey, we've met our criteria, we don't need to buy anymore, we don't need any more in here. Again, it's a sliding scale. It may happen, but I think the way this industry is going, there's enough push to, if we can make it and it's renewable, we need to do something with the utilities to get them to take whatever can be produced. So it's possible they may stop net metering and they may stop taking renewable energy sources, but my gut feeling is, there's going to be enough power. Here again, you got Revision Energy in our extra office alone, we got 25 people working. And, it doesn't take much to go to our legislators and say, hey, we got 25 people working because of solar. Are you going to screw up this legislation and put 25 people out of work? That's the message that usually the legislators need to hear. They're going to be putting people out of work.
How close are we to that 50 megawatts right now,
I don't. I know it's been a point of discussion, so it's starting to come up. It's on our radar screen as an industry, and we need to start doing our necessary lobbying to make sure we don't run up against it. But I don't think it's imminent in the next year or so.
Well, you're talking about the utilities need to be buying renewable energy. So if they've got that limit at 50,000 megawatts, whatever it is, and we're reaching that with solar, why do we need wind at all? Yeah, this is one of the things when they came to do Wild Meadow there, I live right across the valley from it, right outside of my house, was if the federal government had given subsidies to local companies to build solar in these large arrays, like you're saying, these large metering systems,
There would be no need for it.
It just would have made a whole lot more sense instead of some foreign company getting the tax incentives.
Absolutely. And watch, the utility industry is a huge lobbyist, as we've seen the windmills. And they've got quite a bit of influence still even with the solar market. So they're pushing back on this too. And it really requires us as a community, me working for a large employer in New Hampshire, to say, hey, this is an economic benefit to New Hampshire. It's keeping people employed. It's maintaining our quality of life. You need to be progressive and look at what your legislation is doing. One of the things we're running up against is with the residential systems, that $3,500 rebate, there's a match up to 10,000 kilowatt hours per year. So they won't pay you that rebate if you've got, if you've got a system that's larger than 10 kilowatts. And what we're finding now is that's unrealistic, because one of the directions we're trying to move people to is using more electricity with technology that's very energy efficient to heat their homes. So we're not just dealing with plug loads at people's houses, we're encouraging them to use it for hot water, electricity to heat hot water, electricity to actually heat your house, and we're running up against that cap. Residential systems can be larger than 10 kilowatts. So that's one of the things we're trying to lobby for. Commercial, it's up to 100 kilowatts, which is nothing. In Massachusetts, they're building megawatts, 10 times that size. It's very common. And we've got this cap right now that's at 100 kilowatts. Now, to their credit, they just had a meeting a couple couple months ago saying, what can we do? Can we increase that? But, this required some forward-thinking legislators to realize that this is the way we need to go, and they can't be suppressing this market, is my gut still.
I'll take the moderator's prerogative for the last question before we wrap up, and then we can, as we're breaking up, you guys can talk to Craig for a few more minutes. There's different, you mentioned different rebates, New Hampshire Electric Co-op, state, federal, et cetera. Where is that funding coming from?
The majority of the funding from the state, the utilities can either get their renewable energy power, they either generate themselves or they can purchase that power. Usually the way they purchase that power is what we call renewable energy credits, RECs. And they buy so many of those credits, they basically take the ownership of that renewable energy credit, and they can say, hey, we're getting so much of our power from these RECs. If they don't buy the RECs, then they pay what they call an alternative compliance payment. So they basically pay a penalty or they buy the RECs. And the funds that come from that alternative compliance payment is what actually funds the state rebate. So that's where those funds are coming from. Here again, this is another legislative thing. It puts some artificial, those RECs should be on the open market and sell for what the market requires those RECs to be. Right now, the current legislature's got caps on those things. So, this is additional income you potentially receive, and there's a market. They're selling for about $40 to $45 in New Hampshire right now. In Massachusetts, they're over $250. And the only reason they're not at that level now is because of the current legislation that's put a cap on those. Yeah, I should make that pedestal.
Oh, that's good. Craig, thanks again for speaking to us.